Welcome back. We are continuing annuity due. In our previous session, we looked at annuity. We tried to understand annuity and then we looked at annuity immediate as one type of annuity. We looked at the present values and future values involved, and we want to now look at annuity due. Annuity due is the same as a series of regular payments, but payment is made at the beginning of the period. So that's the distinction between immediate and due. With immediate, payments are made at the end of the period, but with due, payments are made at the beginning of the period. So given this timeline, with annuity due, you pay before the period starts. So if you are making a payment of one for every period, you pay at the beginning. This is period from 0 to 1 is period one. So you pay at the beginning of period one, you pay at the beginning of period two, at the beginning of period three, all the way. So your last payment will be at n minus one. Alright, n minus one. Okay. So how do we then represent annuity due using actuarial notation? Anyway, I would like to think about such payments. What kind of payments do we usually use? Do we pay at the beginning of the period? Sometimes I don't know, you can think about it. What payments do you think usually are made at the beginning of the period? What's coming to my mind is pensions. When you subscribe to a pension fund and you actually retire, once you retire and you start being paid at the beginning, right when you retire, and that's a period of. So if you are being paid if you retire at 60 and you are being paid from 61, the amount will be given to you right from the beginning of when you retire, that's age 60, and you enjoy it for that 1 year period. Think about other forms of payments where payments are made at the beginning of the period and we can discuss in class. So to represent this actually, the present value of annuity due is given as A and NI, but with two dots on the A. So this is how different this is from the annuity immediate, okay? The two dots on the A. So with this payment, remember you are paying from times zero. So the present value of the series is 1 at times 0. 1 now is just 1. There's no interest involved. So it's 1 plus 1. The present value of 1 at times 0 is 1 times V. So I'll take away the 1s times the V. The present value of 1 at times 2 is 1 times V squared. I remove the 1. At time 3 is V to the power 3. All the way to V to the power N minus 1, which is the last payment. So to find the present value of this one at time minus 1 here is V to the power N minus 1. So you can once again use the summation of geometric series to find your present value of annuity due. Okay, so you can try that, and if you simplify it, you should get 1 minus V to the power N all over D. So the difference between this present value of annuity due and then the present value of annuity immediate is that for immediate, the denominator is I, which is the interest, but for due is D. Now D is equal to I over 1 plus I. Okay, it's a notation that is used to represent I over 1 plus I. All right, good. So you can also find the future value of annuity due. That's the value of this series of payments at say time n. You want to find the value of this series at time n. I mentioned earlier on that you can find future value at any time based on where you're referencing. So to find the future value of this series at time n, S angle n I is due, so double dot is equal to my present value multiplied by my accumulation factor, which is 1 plus I to the power n, and simplified to get 1 plus I to the power n minus 1 all over D. This is very similar to the case of annuity immediate, except that the denominator is no more I but D. So take note. Okay. Let's try our hands on an example. Good. Okay. So with this example, a company wants to provide a retirement plan for an employee who is 55 years now. The plan will provide her with an annuity immediate of 7,000 every year for 15 years when she retires at 65. The company is funding this plan with an annuity due of 10 years. If interest rate is 5%, what's the amount of installments the company should pay? Okay. This is quite a packed question. I want to look for a simple question for you and then we'll look at this one. But I think since we solve very simple questions and it's immediate by simply locating the parameters involved and fixing them in the formula, let's give an attempt to this question, even though it's a bit packed. Okay, so the person employee involved is 55 years now. He will retire in 10 years time. Okay, so let me draw my timeline. Currently 55 years. So 55, we have 56, 57, all the way to 64, 65, 66. And it's been provided, the question says that the plan will provide her with annuity immediate of 7,000 for 15 years. So once she retires at 65, she'll be receiving 7,000 immediate. So at the end of every year, all the way for 15 years to age 80. So her last payment will be at age 80. She received 7,000 at age 80. Great. This is immediate. So once she turns 65, this is period 66, 65, 66. So payments will be at the end of the period. Okay. Now, interest involved is how much? I is equal to 5%. Okay. So the company wants to fund this. It's something they want to do in the future. They want to know how much should you put down. The company wants to provide a retirement plan for the employee who is 55 years now. Okay, the plan will provide her with annuity immediate of 7,000 every year for 15 years, which is established year after she retires at 65. The company is funding this with an annuity due of 10 years. So the first 10 years is what they're going to be using to build the fund that we can now pay when she reaches her retirement because she's now 55 years old. Interest rate is 5%. What is the amount of installment the company should pay? Installment means regular payments. Okay, so what should the company be paying is due. So it'll be paid. She's 65 years now. So once annuity due, we'll pay from now at the beginning of the period. So we'll pay some amount X, which we don't know, at the beginning of each period. So the last payment, which is at the beginning of a 65th period. Okay, so we'll pay the last payment at age 64. So 55 all the way to 64 with X payments is 10 payments. All right, so there are 10 payments involved here. You can be referring to this example in your notes, the statement of the question in your notes as we go through the solution so you don't get confused. I cannot present the question here, so just look onto your notes, the example in your notes, and then refer. The actual demand of this question is to find X. What is X? So, if you want to find, for example, let's make 65 here a reference point. I told you can choose any reference point in your period, even though in working so far, you're using the begin and the end of the period as a reference point. I choose 65 as my reference point. Now, if you want to find this payments you want to do in the future with this, then the value of this x's, all these x's, the sum, the future value of this x at time 65 should be the same as the present value of these 7,000 at times 65, because you want to fund this, with this. Okay, so I expect that the future value of this series of payments at times 65 will be the same as the present value of this series of payments at times 65, because I want to fund this with this, and they are using the same interest rate. So what's the value of this series of payments x at times 65? It's a future value of an annuity due. So S dot double dot angle N. There are 10 payments involved. I is 0.05. Okay. So we want to find this, but remember the payment is X. So we write our X here, which is times S double dot angle 10, 0.05. Okay. Alright. It's 10 and not 65 or 55, because the period is N. N means how many payments are we making? How many payments? It didn't start from times 0. Take note. That's how come you're not seeing maybe 0 to 10. But the N is focused on how many payments. So S double dot angle 10, interest is 5%, should be equal to the present value of this series of payments at time 65. They are using the same reference point. Once you consider this series of payments at time 65, you're looking at annuity immediate, because you can see that payment is being made, choosing this reference point, payment is being made at the end of every period. So this is equal to 7,000 times A. There are 15 periods here involved. 15, 0.05. Okay. So once you can open up this expression or this equation, you can solve for x. So x, this is from our initial lesson, 1.05 to the power n, which is n minus 1 over what? D. And d is equal to 0.05 over 1.05. Okay, so over 0.05, 1.05 is equal to 7,000 times what? 1 minus v, which is 1.05 to the power minus 15. Okay, all over 0.05. So this is a very long equation. You can use your calculator to simplify this, and then you find x. So the value of x you are expected to get is 5,501. I may make a mistake, so please make sure that what I've written here you also verify to be correct. So this brings us to the annuity due. Let's meet again and look at the final session.